Assalamualaikum and hi to everyone, and to our lecture. Right now we're gonna present for final project for engineering workshop 2, and the project is the heart-shaped LED PCB project. Well, let's get started. Okay, before we begin, let me briefly introduce to our team. Our team consists of 2 people, me, Muhammad Lutfi Rahman bin Osman, with metric number B122510005, and I'm responsible for the circuit design and PCB layout. And for my partner is Clement Kanaraj Anlaki Saranjang Kutuvan with metric number B122510442. He mostly in charge of component soldering and circuit tester. Okay, for the introduction, the heart-shaped LED project is a simple electronic circuit that creates a running light effect using 8 LEDs arranged in a heart-shaped shape. The circuit uses a 555 timer IC to generate a clock pulses and a CD4017 decade counter to switch the LEDs on one by one in sequence. This project demonstrates the operation of timing and counting circuits while providing hands-on experience in the circuit design, PCB development, soldering, and troubleshooting. Okay, for the introduction, the main objective of this project was to design the circuit, verify its operation through the simulation, develop the PCB layout, assemble the hardware, and improve our practical skills in PCB design and electronic circuit development. These objectives allowed us to experience and complete PCB development process from designing to testing. The main objective of this project was this slide shows the bill of materials used in our project. It lists the component required for the circuit along with their quantities, and the boom helps ensure that all the necessary components are prepared before the assembly begins. This slide shows the bill of materials used in our. For this project, we used Proteus software to design and simulate the circuit before creating the PCB layout. We also used a soldering station for component assembly and a Dremel workstation during the PCB fabrication process. These tools were essential for completing the project. For this project, we used Proteus software. The main components used in this project include resistors, capacitors, a 555 timer IC, decade counter IC 16CD4017, and red LEDs. Each component plays an important role in producing the sequential running light effect of the heart-shaped LED display. The main components used in this project include the circuit was designed using Proteus ICs. The 555 timer IC was configured to generate continuous clock pulses, while the CD4017 decade counter received these pulses and activated each LED one after another. This simulation helped us verify the circuit before proceeding with the PCB fabrication. The circuit was designed using Proteus ICs. The 555. In this slide, it says about the PCB layout and the fabrication. The schematic was transferred to produce arrays to create the PCB layout, and the PCB tracks were routed. Then the board was fabricated by printing, etching, and drilling and cleaning it. Finally, all the electronic components were soldered according to the PCB layout. Okay, thank you. And now I will hand over the presentation to my partner, Clement. Okay, on this slide, it says about.
As for slide 10, during the testing, PCB did not operate as expected and the LED sequence could not be observed. We carried out several troubleshooting steps, including suspecting the PCB, resoldering the solder joints, installing an AC socket, and checking the power connections and component replacement. Despite these efforts, the PCB remained unfunctional, so we verified the circuit again using a breadboard prototype. As for slide 10, during the testing, PCB did not operate as expected. As you all can see for slide 11, verification live demo, the breadboard prototype followed the same circuit systematically used in the PCB design. During testing, the LEDs operated sequentially as intended, confirming that the circuit logic was correct. The verification showed that the design itself was fundamental and functional, although the physical PCB will be encountered implementation issues. After this, we will be demonstrate the breadboard operation. As you all can see for slide 11, verification live demo, the breadboard prototype followed the same circuit systematically used in the PCB design. During testing, the LEDs operated sequentially as intended, confirming that the circuit logic was correct. The verification showed that the For slide 12, results and discussion. Overall, the circuit was successfully designed and simulated before PCB fabrication. Although the assembled PCB experienced implementation issues during hardware testing, the troubleshooting process helped us improve our understanding of PCB assembly and fault diagnosis. The successful breadboard verification confirmed that the circuit design was correct and emphasized the importance of careful PCB implementation and testing. For slide 12, results and discussion. Overall, the circuit was successfully designed and simulated before PCB fabrication. In conclusion, the project provided valuable experience in circuit designing, PCB fabrication, soldering and troubleshooting. Even though the fabricated PCB encountered implementation issues, the breadboard verification confirmed that the circuit design functioned correctly. Overall, the project strengthened our practical knowledge and problem-solving skills in electronics engineering. In conclusion, the project provided. As we go for the next slide suggestion, for future improvements, we recommended checking the PCB routing and components footprints carefully before fabrication. Individual sections of the circuit should also be tested before final assembly, followed by continuity testing to detect wiring faults. These improvements can help reduce errors and the overall reliability of the project. As we go for the next slide suggestion, for future improvements. Thank you. That concludes our presentation. Thank you very much for the time and attention. We welcome any questions or comments regarding our project. Thank you. That concludes our presentation. Thank you very much for the time and attention.